Okay, good morning, everybody. How are we doing? It's nice to see you all this morning. We'll wait for a few people to enter the room and then we can get started with our live today. It's nice for me to introduce Przemek, who's here with us from also from the dive center, actually.
Yes, I just flew all the way up to UK, although there is no flight.
You don't know, otherwise people send you messages asking why you're not staying home.
Are we sure we are online? Because I have your fan page on and I don't see it.
Yeah, it says it's live on my one.
Okay, maybe it's there's the delay.
8 people already joined in, according to it.
Good morning, 8 people.
9 now. Let's try again. Okay, good. So I can see the live now. Morning, Sam. Good morning, Rob. Dave, how are we doing? Simon James, Stuart Acklam. Hi, how you doing, buddy? You should be in the garden, apparently. So I won't tell your wife. Don't worry. Okay. So we get a few people entering the room now.
Yeah, also not easy. The good idea was to wait like 5, even sometimes 10 minutes because people are always late, preparing the coffee now and so on. Huh?
We'll wait for people to catch up and join in. But nice looking rEvo there with a nice black cover. I noticed that's the special edition version.
Yeah. I have it on as well to show, so I will show both units actually because I have a micro and a mini here, so not only the black one. Do you see the unit clearly, Adam?
Yeah, I can see the unit really clearly. It looks fantastic.
Okay, good.
Here comes Mark Crane, Paulo from Portugal, Ludo from Mauritius, Inupun, I think, from Thailand, Mata from Italy, and Simon from the UK. So a few people joining us now. It's nice to see you all. In the next kind of 2 or 3 minutes, we'll get started. It's an interesting one today because I won't be hosting it. I'll just be asking a few questions, and it'll be hosted by our friend here, Przemek from Poland. But he looks a lot like he's in the dive center with his background. The idea is to go through in the same way we went through the other rebreathers to talk about the rEvo. So at that time, I'll turn my camera off, but I'll be in the background. Still, please feel free to ask as many questions as you like. Just write them in the comments. We'll get to them as and when it's appropriate. So we'll stop the video, we'll stop doing the build up at some point and jump into questions, and then we'll carry on. The rEvo is a really nice rebreather. I am a diver of the rEvo, but not an instructor, which is why it makes sense that the Przemek comes to you and gives you the full rundown and can answer all of your questions. So we've got 25 people in the room now. So I think it makes a good time to start. So Przemek, I'm going to switch my camera off now, and you can introduce yourself to the guys and show them this awesome rebreather.
Sure. So hello everybody. Thank you, Adam, for inviting me to do this presentation for you. My name is Przemysław Peszczak, but because nobody can pronounce it, you can try to pronounce the shorter version, which is Przemek, and then the easiest one is PK. So I'm a SSI International Training Director. I'm mainly focused on the rebreathers. I mostly dive the rEvo. That's why Adam probably invited me to do the presentation for it, because I probably know the unit well. I'm from Poland, and currently in Poland, I work for SSI. I'm an SSI representative for Poland. And at the same time, I do all the training stuff for SSI, XR, rebreathers, and so on. I'm also an Horizon trainer. I had the privilege to be a part of the Horizon development team, both for the materials and the unit itself. So basically my life goes around the rebreathers for a pretty much long time now. So today we are about the rEvo. So the objective of this presentation is to show you the rEvo, explain you the rEvo, show you the pros and cons of the unit. So I will try to do it the same way as Adam did before. So I will explain you the unit, I will show you its advantages, I will show you how to build it up, I will show you how to prepare the unit for diving, and doing it, I will point these nice features of the units I think are worth to mention. So let's start then. In the beginning, the rEvo is manufactured in Belgium. It was designed by Paul makers in Belgium. This is the hybrid CCR, we call it. Probably most of you already figured out that we have two kinds of CCRs, ECCRs and MCCRs. Basically, the difference is about how they provide the oxygen into the diver. And usually the ECCRs, they are only electronically controlled by the computer, the solenoid, and the manual are not. They have a constant flow of the oxygen, and then the diver has to maintain the PO2 manually. The rEvo has a little bit of both. I'm going to explain you a little bit more about this later on, but we have both, let's say, both parameters, both options on the rEvo HCCR. We have the solenoid that is electronically controlled, and we have also the constant mass flow and, of course, the manual injection. So I'm going to start with the sizes, because those of you who were looking on the website, maybe or was interested about the rEvo, probably you found the information that there are three sizes of the unit. We have micro, mini, and the standard. And the sizes are all about how well they fit your body. So the micro is the smallest one, mini is the middle one, and the standard is the tallest one, the highest one. You can see the dimensions on the rEvo websites. But what is important for you to understand that all three units, they have exactly the same parameters. They have the same scrubbers. They may have the same tanks installed. They have the same duration of the dives. The only difference is the housing size and the counterlungs volume. Actually, the counterlungs volume is the same. I mean, the counterlung inside is the same. It's just the housing is smaller, so the counterlung can expand less. So that's why the practical volume is less. Although the micro has a 5.5 liters of the volume, the counterlungs, to be honest, I never met a person who needed more for diving, even if they need to breathe very heavily. So actually, the only one practical difference between those three sizes, micro, mini, and standard, is basically the size. And about the size is very simple. So why would we want to have a big and heavier unit if we can use a smaller one? There's no reason. If you can dive with the rEvo micro, there's probably no reason, the micro, the smallest one, there's probably no reason to buy a bigger one. They might be two. The first one is simply reaching the valves, because the rEvo, to have the best breathing performance, needs to be installed as high as possible on your back. So if the unit is as high as possible on your back, obviously the valves are also a little bit high. So if somebody is a very tall person, like, I don't know, 190 or 2 meters high, then maybe he will have a problem to reach the valves when the unit is very high on his back. Valves are on the bottom, of course, of the units. The tanks are, the tank valves are on the bottom. So if you will install the unit high enough or properly high, then if you are a very tall person, especially with some movement restrictions of your arms, you may have a problem to reach the valves. That's why you might have slightly higher unit, like mini or even standard, so you can reach the valves easily. The second reason that you might want to have something bigger than micro is the weight. I will talk about the weight of the rEvo also a little bit more in the next part of the presentation. But what now is important to know that the rEvo can also be made of two type of materials, the titanium or steel. The titanium is lighter, it's roughly 2 kilo less than stainless steel. So if you're diving in the cold water with a thick undergarment, if you are using steel, then you may need a less weight because the unit itself is the same dimensions, is the same size, but it's just slightly heavier. I will tell you a little bit later on about the weight on rEvo. rEvo is really nice unit because you don't need much weight with it. So this 2 kilo of the housing difference sometimes is just a difference. Do I have to carry any weights, or I don't have to carry them at all? So if you dive in the cold water, you might consider a stainless steel unit, and the micro, the smallest one, is only titanium. You cannot buy the stainless steel micro. So again, if you can dive with the micro, with your full configuration, you have reasonable amount of weights, I would highly recommend that unit. If you need too much weights with the micro in your environment, with your configuration, your dry suit, wetsuit, whatever you're using, then you may consider, for example, the mini and then also the steel version, because it will be slightly heavier, so you don't need to put that much weights on the unit. And the standards is not many people actually are using standards. I was using ones in the very beginning. My first rEvo was actually the standard one. I like that. But it's much heavier and much bigger on your back. So if you don't need that unit, I don't see any reason to use it. So the sizes are all about how the unit fits your body. There is no any difference. It's not like you cannot dive. You can dive deeper or you can dive longer or whatever with a bigger unit compared to the smallest one. They have the same scrubbers. The same tank can be installed. And so everything else is the same. It's just the housing. It's just about how they fit your body. So this is about.
This is the rEvo 3, right?
Yeah.
Was the rEvo 1 and 2 available in the same materials, or just the 3?
I'm only talking about the rEvo that is right now on the market in regular style, because rEvo 1 and 2 are of course not anymore available. Maybe the second-hand unit. So the rEvo 2 was the size of the standard. The micro came with the rEvo 3. So this is about the sizes. And rEvo 1, to be honest, I don't even remember, because I was not even diving the rEvo when there was rEvo 1. I don't think that there was more than a few units actually on the market. It was just testing, or Paul was just testing those units, I believe. So yeah, I'm talking about the rEvo 3, the one that is right now, and actually the only one with the CE certification. So because we should not dive the units without the CE certification, this is the one that we are considering. Okay. So let's move on then. So this is about the sizes. Then, as I already told you, we can put any tanks on the rEvo. I mean, any tanks that will fit. So 3-liter tanks, 2-liter tanks, all the type of rebreather tanks will fit. rEvo has a really nice feature for installing the tanks. We call this tanks fixation. I will just now show you how easy it is to put the tank on and off. So now I just took the oxygen tank off. You can see that there is a steel or titanium part with 4 pins. Those pins slides into the housing, and there's a locking pin that locks the tank on the unit so that the tank doesn't come off. And then you just use steel cam bands to connect those tanks fixation to the tank. So wherever you're using this 2-liter, or you can use just 2-liter tank, you do it exactly the same way. Since 2 years, I think, we have also what we call the travel tank fixation, which basically works on the same principle. We have this 4 pins and the locking system. So I just slide it in, and then I can use that standard tank buckle to put it on the unit. So it's a little bit more convenient when you travel, because you don't have to take the tanks with you. You can rent the tanks on the side if they do rent the tanks, and you just take your travel logs with you, and then it works very simply, very fast. it's just a little bit more work to take the tank off, because you have to do and undo this buckle every time, or actually you can also, it's the same way, to take this whole tank fixation off. Once when you have your own tanks, usually people are using the standard tank fixation, because on the rEvo it's quite important to align the tank correctly here, because if you do it in the wrong orientation, then it will be a little bit confusing here, and you will not be able to turn on the first stage, put it on the connected to the valve, or the tank will be too much outside the unit. So it's a little bit work in the beginning to align those tanks correctly, but once you do it, they are fixed and are always correct, so you don't have to worry about that, and you can very easily and very fast put the tanks on and off the unit, which with this travel quadlock is a little bit more work. With this fixed tank fixation, it's simply like this. You slide it in and it stays there, so it's really nice. So you can put here any rebreather tanks. You can put 3-liter tanks, you can put 2-liter tanks. There are also 3 liters thicker tanks available in rEvo that are slightly smaller, so they end up like here more or less, but then they are a little bit more in the diameter. So any tanks for the rebreather will fit the rEvo. So the main difference, what differs the rEvo the most from other units, is actually the design. So Paul, the designer, when he was designing the rEvo, he was thinking completely out of the box. What I like to say is, when you look on every rebreather on the market, they have a lot of similarities. They have counterlines, they have the head, they have the scrubber canister, they have breathing hoses, they have T connectors, they have DSVs or BOVs. So I'm using this simplification, or actually the example that if you take 5 units and you just disassemble them and you put all the parts into one big box, and you imagine that all the threads and all the connections fits together. So there's one thread for every T connector, one thread for every breathing hoses, and there's one thread for every canister, and so on. You could actually build the unit using the counterlines from JJ, the head from AP, the housing from JJ again, then the second counterline from, I don't know, Poseidon. Then you can take the DSV from AP, and you will build the unit, because they all have exactly the same design. Like if you create the scheme of the rebreather, you will have all the same parts more or less in the same place. They of course differ each other with the materials they are designed, with electronics that is used, with the size of the scrubbers. But in general, they are more or less the same. We have the counterlines, we have the DSV or BOV, then there's a hose, exhale inhales going into the TPs or T connector that are connected to the counterlines that are somewhere on your shoulders or on your back. Then the second hose goes to the scrubber canister, then the gas is passing through the scrubber, and after the scrubber, we have our electronics or our head or our E-module, whatever you call it, where all the magic happens, which is the sensor analyzes, the oxygen injections, and so on and so on. So this is very similar to every other unit but rEvo, because rEvo has completely different design. We don't have such a thing like head or electronics on rEvo in one place. It's not like you can just find this most expensive part of the rebreather, which is the head, and just remove it, and then you have sensors, solenoid, and all the electronics. There's no such things. It's all divided into several parts of the rebreather. The second thing is that everything is closed in this titanium or stainless steel housing. So everything is inside there. All the counterlines, which is a huge advantage. There is no counterlines outside. What you see here is just a wing. There's no counterlines completely available from the outside, which is a good protection from the damage. You can actually see, if you take a close look here, you can see actually the bladder inside, that's the actually counterlines. So they are completely closed in this housing. Also, the other difference, which you will notice probably very, very fast, that we have only one inhale and exhale hose. We don't have this standard connection like every other rebreather does. I mean, let's say 95%. I don't know every rebreather out there, but most of them. So we don't have a, let's say, inhale or exhale hose, then the key connector, the counterlines, and another hose. We have only one hose that is connected directly to the housing, which is connecting that hose directly to the counterlines. That solution gives us incredible freedom of movement under the water. The first impression and the most common impression that people have when they try the rEvo after diving other units is freedom of movement. Depends on the unit. Usually when you put this unit on your back, also depends if it's front mounted counterlines, back mounted counterlines, or whatever. Those units differ in how free you are under the water, but it's never as free as open circuit. I'm sure everybody who are diving any rebreather will agree that. And on the rEvo, it is really, really nice from this perspective, because we have only one hose, which is actually very nice silicone hose. So there's no TPs that are actually restricting our movement or limiting our movement. There is no counterlines outside that makes us more bulky here. So basically, this is very, very comfortable unit to dive in terms of the movement. And for example, if you want to turn your head left or right, there's completely no problem. You don't even feel that something is resisting your movement. So if you want to take a look on your body on the left or on the right side, there's many units, especially the one with the front mounted counterlines, when you have to move all your body to see anything around. This is not the case with the rEvo. So this is really nice feature. This is really nice the way it was designed. So the movement under the water is very, 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 very nice. In the front, we have our wing. This is actually the Mares wing. I put it. This is my personal unit, so it's a little bit modified, but only just to have fun and play with other parts. I was wondering how the Mares leather will work out with the rEvo. To be honest, I didn't notice any difference between this one and the standard rEvo wing. And also the harness. I put here a standard webbing harness just with the one hook here to make it easier to take off. Usually the rEvo from the factory comes with a adjustable harness. I'm going to show you this harness in a minute on other unit. But if you think about now, this is really comfortable in the front, because here we have only the harness. We have nothing else. This is my side wheel binder, so you don't have to worry about that. So once you put your unit on, the only thing you have in the front is actually your wing inflator and your manual edition and MAV. I will explain you a little bit more about this later on. So this is very comfortable unit to dive because of the design. We don't have anything in the front, just like we're diving twin set. There's only the harness, there's the wing inflator, and there is one additional device to manually inject the gases. Also the pressure gauges, you can nicely route them along the harness, so they are not dangling down, that you have easy access for them. So you can make a really unique, nice, streamlined and clean in the front. So the next difference, because I'm gonna tell you the major difference between the rEvo and the other units, and then I will go to the details. Then the second difference is the design of the gas pathway, let's call it. Because if you think about how the gas is traveling in the rebreather, so from the exhale into the inhale hose, on the rEvo, everything is 90 degrees angle, which means the gas is not traveling from the bottom to the top. The gas is actually traveling, the point is nice. The gas is actually traveling like from here to here, down and here. So this is this is a different, but what that gave us, what was the advantage of this solution is actually the size of the unit. Look, if you look on the side of the unit, so the diameter here, so from the highest point on your back to the diver's body is 180 millimeters, which is basically the twin set size. So the unit is really nice because it's not far away from your bodies, which especially the cave divers or the wreck penetration divers like that solution, because the unit is actually not so tall. So this is the thing. The next thing is the scrubber design. And this is probably the biggest difference, because if I show you the scrubber on the rEvo, it will be completely different than every other rebreather out there. So rEvo has 2 scrubbers. So the design of the rEvo is that it is a dual scrubber rebreather, and those 2 scrubbers, they're installed in series, which means the gas is traveling first to the first scrubber, then it's going to the second scrubber. So it's just like a 1 scrubber, but it's cut by half. Actually, if you look on the scrubbers, they look exactly like this. If you connect them together, you will have pretty much similar thing that you already know from the previous videos of Adam, like a AP scrubber or Poseidon scrubber or JJ scrubber. Actually, the size would be almost identical, because each of the rEvo scrubber has 1.35 kilos of the line in it. But the advantage of it is much more than the size. So here inside the unit, we have 2 scrubbers. And what I'm going to do now, I'm going to explain you the unit using the gas pathway. So I'm going to explain you part by part of the rebreather, from the moment when the diver is exhaling to the moment when the gas makes a full circle and comes back to the diver's mouth. And then I can show you all the features and all the parts that the gas was traveling through. So of course we start with our mouthpiece. So we have a DSV on the rEvo. Now there is options to also have a BOV on the rEvo. It's actually the Horizon BOV that was adapted to rEvo, but this is a relatively new thing. So there's a simple working principle. Up, the loop is open, we're breathing from the rebreather. Down, the loop is closed, we are breathing from the rebreather. By the default, we have the gag strap on the rEvo. This is really nice feature, which many divers don't like. But what I like to say that the people who are not using the gag strap are just because they didn't get used to it. It's just like a snorkel. In the beginning, when the open water divers start to dive, the snorkel is only disturbing thing. They always try to find the inflator, they hit the snorkel, or they want to find the snorkel, they hit the inflator, they don't like it. But it just takes time to get used to it. And once you get used to the snorkel, it's very useful and nice tool to have. It's exactly the same with the gag strap. Once you get used to it and you build yourself a muscle memory of using it, this is a really great thing. First, it helps you to keep the DSV in your mouth. So in the long dives, you don't feel that much of the fatigue on your jaw or on your mouth while holding the DSV in your mouth. But what's more important is, of course, the safety. I know few stories I cannot tell you in public when the gag strap actually saved people's life. And unfortunately, I know at least 2 when not having a gag strap on didn't save the life. So this is really actually nice feature to have. I know that there's some other units that also have this as an option. I highly recommend to use it. If you try it and you didn't like it, even on other units, believe me, you have to just get used to it. Once you get used to it, it's very brilliant, very comfortable to use. Okay, so the diver inhales. The rEvo, actually, the gas is traveling from the right side to the left. So pretty much the opposite than most of the units. So this is our inhale hose. The diver inhales, takes the oxygen, produces the CO2, and then the gas goes to the exhalation hose here to our exhalation canter lines. So now it's really difficult to show you this in the camera, so you have to use a little bit of your imagination. But if the gas enters, maybe I will take the fan off, it will be much better. Okay, so once the gas enters here, the counterlines, it is exactly coming here. Now, what I just did, I just put my hand inside the counterline. I can actually touch my exhalation hose right now from the inside. So here, what you can see is actually the inside of your counterline, of your exhale counterline. So this is why we open exhale counterline, which gives us a really nice feature, because we can very easily dry the counterlines inside. What you see now is inside the counterline. So after the dive, you just simply leave it open like this. If this is the boat on the wind, sorry, if this is the boat with the wind without too much waves or splashes, you can leave it like this, and after 10 minutes, everything is completely dry inside. So in the exhale counterline, we call it solenoid tray, and the solenoid tray is the place where all the gas management has place. So what we have here the solenoid, we have here the ADV, and we have here our sensor board. The sensor board is the first computer in the rEvo. Remember, I told you that in the rEvo, the electronics is spread around all the unit. So this is one part of the electronics. This small black rectangle is actually one of the electronics. There is a circuit board inside. It's connected to the solenoid. And this one is actually responsible for firing the solenoid if it's needed. Here, there is a connection with a wet metable connector. This is the digital connection, the CAN bus, the same that is used in JJ, in SF2, I believe, as well. So this is a digital communication where all the data is traveling from our sensor board to other computers, which I will explain in a minute. What we have here as well is our constant mass flow. So I pointed to this part as a solenoid, but actually what it is a solenoid and the orifice in one device. So the orifice is actually built in the solenoid. So the solenoid is firing, the oxygen comes from that hole, and the CMF, constant mass flow, or the orifice is injecting the oxygen or leaking the oxygen constantly from that hole. So here we constantly have a little bit of the oxygen leaked in through the constant flow, and then there is a solenoid that fires if our partial pressure drops below the set point. I will get into that solution a little bit more in the detail once I finish explaining all the units. So here, all the gas management happens. So once we inject the oxygen, if it was necessary, maybe we inject some diluent through the ADV if that was necessary, then the gas is traveling to the first scrubber. Okay, so the gas is going like from the bottom to the top of the scrubber. So here, actually, the gas is coming out from the scrubber, and if everything goes well, everything was fine, we are using correct scrubber rotation system, which I'll explain you, and if we are using correct scrubber duration times, all the CO2 is removed in the first scrubber. The second one is a safety margin. So if everything works well, all the CO2 should be removed here. So if you were paying attention on Adam's video, you probably noticed the fact that on every rebreather, there was always an O-ring that was actually sealing the scrubber, so the gas with the CO2 is not traveling around the scrubber, so it will bypass it and no CO2 will be removed. There is no such an O-ring here on the rEvo. So this, in the beginning, looks a little bit confusing because we all know that these O-rings are very critical in every unit, because if that O-ring is damaged or you forget to put it in, You may have the CO2 breakthrough because the gas will just simply travel around the scrubber instead of through the scrubber, and the CO2 will be not removed. It turns out that there's completely no need for that O-ring, and this is for two reasons. Remember that the gas will always choose the easiest way to pass through. So, because the scrubber has a very low profile, it's simply that small compared to, let's say, other units scrubbers that are mostly twice higher. Of course, the scrubber material creates the resistance to flow. So if we don't seal that surface in other units, the gas will have the easier pathway to go around it instead of through the scrubber materials. Turns out that if the scrubber is that high, the resistance of the flow through that scrubber is actually lower than around the scrubber. Also, there's a special shape of that side of the scrubber that creates resistance. And then the last thing, once we start breathing, we create the humidity, and the humidity is collected here around the scrubber or here around the scrubber. That simply works again as a sealing solution. So this being said, there is no scrubber O-ring on the rEvo, and even without it, there is no CO2 breakthrough, which was tested on the sea conditions and proven that it works, which is really nice because there's one O-ring less, one crucial or critical O-ring less on the rEvo, which makes the unit a bit safer. So the gas was passing through the first scrubber. We call it a top scrubber because it's on the top of the unit. And now the gas with the CO2 removed is traveling along the cover. You can see that here we have the passage. So the gas is traveling exactly here. So now this gas is traveling here to get to the second scrubber. What is happening here, the gas is getting into the turbulences, so it's actually mixing even better. So if there was the oxygen injected in before the first scrubber, it now is correctly mixed. And also, if there was any slightly amount of the CO2 that passed through the first scrubber, now this gas will be nicely mixed before it gets to the second one, which means the CO2 will be distributed, this leftovers, small amount of the CO2 will be distributed equally on all the surface of the second scrubber, so it will be immediately removed if any. So now we are closing this cover like this. We have here two O-rings on each scrubber compartment to simply seal it. And also this scrubber cover is playing a role of the thermal protection. Also that closes, seals, and allows the gas to pass through and go to the second scrubber. On the second scrubber, as I said before, if everything was fine, there's no CO2 should be present. So this is just our safety margin. So the gas is just passing through. And then after the scrubber, we have our sensor tray. Our sensor tray is simply the plastic tray with 5 oxygen sensors. I'm going to explain why 5 when we discuss electronics, but the rEvo can have up to 5 oxygen sensors. So here, the gas that is already CO2 removed, the gas that is oxygen, that has oxygen injected in it, is analyzed. So actually what we see on our electronics is after injection, after removing CO2. So we see exactly the gas that will be inhaling in a minute, because here, what you can see actually is an inside of inhale counterline. If you look on the side of the unit, the counterlines are laying down like this, one on top of each other. Here is our exhale counterline, and here is our inhale, and they are connected here, so the gas can only go, can only travel from one counterline to the other, passing the scrubber. So what is actually important for you to notice, which is a big advantage of rEvo design, is the diameter of the hole, let's call it, through which the gas have to pass or travel between the scrubber and the counterlines. So normally those diameter is the T-connector diameter or the breathing hoses diameter, which is much less than this one, which creates a more breathing resistance. So rEvo, because it has a back-mounted counterline, and they are completely back-mounted, because what it's worth to mention is, if we talk about JJ, for example, or AP with back-mounted counterlines, we call them back-mounted counterlines, but they're not exactly fully back-mounted, because they are slightly here on the shoulders, right? And then they go all the way to your back. So what I like to say, that these counterlines are actually not back-mounted, they are just reversed over the shoulder. So just like the standard AP counterlines were over the shoulder, so slightly on the shoulder and on the front. The back-mounted are more or less the same, just on the other side, which gives the advantage of it, because if we have a little bit of the counterlines in the front of our body and a little bit counterlines on the back of our body, the breathing parameters of that counterlines are the best. With the rEvo, we have fully back-mounted counterlines, which means all the counterlines are on your back, which theoretically creates the worst breathing resistance, because there's a pressure difference between your lines and the counterlines, and so we should have not so good breathing performance with the rEvo, which is of course not the true. The rEvo has one of the best breathing parameters from every CE rebreathers. Actually, it's hard to say which one has a better breathing parameter, the JJ or rEvo, because the JJ has 2.0 joules per liter worth of breathing, but this is measured and published with the 75 liters per minute of rEV, and the JJ is 1.8. Adam, I don't remember, 1.85, I think, or 1.90. But
185, I think, yeah.
Yeah, but that is measured and published for rEV 55 liters per minute. So this is, and that has a difference on the work of breathing. So it's hard to compare those. For both units, the breathing is very well. But how did we offset the problem of back-mounted counterline? Exactly by diameter of the gas passage between the counterlines and the scrubber, which is very wide. So the gas is traveling there very easily. So here we have our inhale counterlines, and now if my hand is long enough, I could just put it here and go all the way up, and I will get to my inhale hose when the gas is actually traveling to the diver and everything starts again. So all the circulation of the gas is actually done like this. So if you can imagine, this is a little bit different geometry of gas traveling through the rebreather than every other unit. It's like 19 degrees angle, which has a huge advantage in preventing of channeling. So why is that? Now you need to use a little bit of your imagination. So if you have other unit scrubber, whatever this is, axial, radial, let's use, for example, AP as an example. So the axial scrubber, the gas is traveling from the bottom through the scrubber to the top, okay? And we all know that the channeling occurs when the gas is finding some small channel when it can pass through, and then the scrubbing material around that channel is very quickly used, and then there is no CO2 removed. And the best example of channeling is if you pack your scrubber not correctly, because when, for example, you go on the boat, you are doing this move on the waves, so it's actually like you are packing the scrubber more, then the scrubbing materials goes a little bit down, and then what happens when you dive? You dive in this position. So now, if the scrubber is let's say meshes down, it goes down because of this tapping, you create a channel here, and the gas is passing this channel without CO2 being removed. So because when diver is diving in a horizontal position, this is actually the position of your scrubber, and the gas is traveling from here to here. So if we have any channel on the top of the scrubber, the gas will actually pass it through without CO2 being removed. On the rEvo, the scrubber, if the diver is on the horizontal position, is on this orientation, and the gas is traveling from the bottom to the top, and then goes to the second scrubber from the top to the bottom. So even if you pack your scrubber incorrectly and you have a channeling, you have a channel, you won't have a channeling. Imagine even if this scrubber will be half full, okay, there will be still CO2 removed without being channeling. It just the scrubber duration will be less, but there is no CO2, no channeling possible. The only way that the rEvo can channel is if you are diving in upright position, because then we have exactly the same problem as we had in AP or wherever other unit with the horizontal position and the channeling here. So changing the geometry of the rebreather also prevents the channeling, because simply gravity helps us not to create the channel in a scrubber. So this is actually the one thing, and the second advantage of this different geometry of the rebreather is that we could split the scrubber into two parts. So we have a dual scrubber advantages and a low profile unit advantages. I will take the tank off.
And Przemek, would you mind to answer a few questions for the guys?
Yeah, sure. Go ahead.
So the first question comes from James. He'd like to know, does the gag strap impede bailing out? Does it make it harder to bail out having a gag strap?
Okay, it's a very good question, very often asked by the divers. So actually, the question is no, it does not, because the gag strap, right now this gag strap is the new one. I mean, the new ones, we have it for like 2 or 2 years. Before, it was basically the dragger gag strap, which has a small plastic brackets here, and the idea was that if you need a bailout, you just pull it and you break it, and then the gag strap is completely loose. So that was a good solution, but the problem is that people was afraid to do this during the courses, because this is just one-time use, then you have to replace it. So nobody was doing this correctly. So then now we have a new Mares design gag strap, which basically is super elastic. And what you do actually, when you are bailing out, you close the loop, you pull your DSV just, I don't know, a few centimeters away from your mouth, and then you just simply pull it down. When you pull it down, the gag strap simply falls off your head and is completely loose. So it's not difficult. It's not disturbing of bailing out, but you need to learn correct procedure. When we bail out on the rEvo, we simply close the loop, we pull the DSV down and to the right side, and then the gag strap falls down. So it might sound a little bit complicated, more complicated procedure than without the gag strap. Maybe it is, but it's really worth it.
Okay, awesome. Another question is, what are the options to remove water from the rebreather? James was told at the boat show, if he went in a head down trim position to get the water out, how would the electronics be protected from water?
Okay, so this is the most common question for the rEvo. First of all, the question, how can we remove the water from the rEvo? Exactly the same way as every other unit, through the OPV, because the overpressure valve, I don't know if I will be able to show it to you, okay? Overpressure valve is here, okay? So this overpressure valve is just next to the breathing hose connector. So it is installed on the highest point of exhale counter line. So if you get any water in, if you really want to get rid of it, you can put yourself slightly head down position and simply inflate the unit. It is challenging procedure because you're getting slightly buoyant, but keep in mind that the rEvo countertank volume is 5.5 liters compared to 8, 9, or 12, or 16 in other units. So it's not that big problem. And if we talk about the electronics, all electronics in an exhale counterlines can be completely submerged. You can, what we have here, we have the ADV, we have the solenoid board, which is potted completely, so it's waterproof. Here, the cables that are connected to the solenoid are also waterproof, and the solenoid itself as well. So there's completely no harm in the water on the exhale counterlines electronics. Of course, if you get the water into the inhale counterline, there are oxygen sensors, then they will be damaged, of course. But to have the water in the inhale counterline, that water have to travel through the first scrubber, through the rEvo cover, and then through the second scrubber. So you must really, really have a lot of water inside you will be able to collect too much water there. So yeah, that's the thing. But also, what I very often hear as a disadvantage of the rEvo, which I fully don't agree with, is that the rEvo has a very low resistance for the flooding because of the counterline's volume. This is kind of the truth. If you have 5.5 liter of the counterlines compared to, let's say, 16 on a Poseidon, if I remember correctly, then of course you can put much more water in it before this, let's say, half flooded. But I always say, think about it realistically. What must happen during the dive that you put, like, I don't know, 2 liters of water inside the rebreather? You can get the water inside the rebreather only in 2 ways. One way, you just took the mouthpiece off without closing it, and the second one, you have a pinch hole somewhere. You have a pinch hole in the breathing hoses, you have a hole in the counterlines, one of your O-ring is leaking, so you'll get the water there. So if you have any hole in your loop, so the water gets in through the damaged O-ring, pinch hole, wherever, it actually doesn't matter how much water your unit can take, because it will be fully flooded eventually anyway. You will get this water constantly in. So that this discussion is completely useless. And so the only question is, can I take off my loop without flooding the unit, and how long I can keep it off? So this is actually the way how most of the people are flooding their units. They just forget to close it, or they just jump into the water with the DSV open, or accidentally they just lose their lips, or maybe because of the very cold water for the long time they cannot seal it correctly. So, and for this amount of water, you can easily dive with, because the rEvo, like every other unit, has kind of the water trap, because the counterlines, the exhale counterlines ends up like more or less here. Okay, so all the water can just simply stay there, and you can continue the dive. If you have too much water in the counterline, I know, like probably 1 liter of water will probably already start to be annoying, because we see you gargling. You can try to dump it through the OPV, and this is the procedure.
Okay, awesome. So Sam asks, what material is the scrubber cover made out of? Is it tough, or do you need a cave shield?
You mean this one?
Correct, that one.
Okay. So this is actually double layer material. Here is Berlin, and this cover, because it also, as I told you, is a thermal protection. If I'm not wrong, but I'm 90% sure I'm not, this is highly compressed neoprene. That's why you can look at mine, looks like shit already, is because one day I was traveling with the rEvo in the box on my back, and 2 screws went underneath it, and it was in the plane. So when I opened my rEvo, it was really those, you can see those holes here. So maybe I can show you this angle. You can see this part is very highly compressed neoprene, so it's quite hard, but also gives the thermal protection. And this one here is a Derlin. So I wouldn't use it to nail a nail into the table, but many times I've seen people were dropping it and so on, and there's no damaging of it. We usually use it as a tray. for our scrubbers. So it's actually quite strong. I'm not a cave diver, but I asked this question to the cave diver, and they say that this is very resistant material. Even if you punch the cover with some piece of the rock or whatever, it is fine. So, but it's quite solid. If you hold it in your hand, you can feel it that this is not like, I'm sorry to say that, a piece of plastic. Okay, it's not. It's a really solid piece of delving and connected with a very, very highly compressed neoprene.
Okay, awesome.
That's a neoprene, but it's something that is not fully solid. It's something foam. This is something foamy. I don't know what that's word.
No, perfect. And Martin asks, are there less incidents of hypercapnia on the rEvo because of the design?
That's a good question. I don't know the answer. I'm not following the accidents report, to be honest, because they're all full of bullshit. So I don't know. I've seen once a situation when one of my friends, but that was during the course, beginner course, so a lot of exercise, but breathing patterns and so on, who actually was a little bit hypercapnia, but no, that's not happening a lot, not to my knowledge. So the accidents, when that was serious accident, when the hypercapnia was reported, I don't know, but again, I'm not following those let's say reports much.
Okay, awesome. So Stuart asks, can the diver mistakenly place a used scrubber in the top position and not the bottom position?
Yes, it can. He can, because they are exactly the same. If you do it, it means that once you go back from the dive, because nothing will happen to you if you think about it. If you do it accidentally, the top scrubber will not work, but all the CO2 will be removed in the bottom one. But if you do it, you should get out of the water, take the unit off your back, sell it, and don't dive rebreathers. Because it's very, very simple. We have here a top marker label. So this, I told you in the beginning that we are cycling the scrubbers. So it means that if the time comes and you are about to replace the scrubber, you actually only replace one, because as I told you, if everything is fine and there was no issues, the top scrubber is doing the job. So now I can actually do the cycling, which means I take the bottom one, which is not used, I put it in the top, I replace the top one to fresh line, okay, and then I put it in the bottom. But now what I have to do, I have to take this top marker off. It is just like a screw, and put it here. So I know that now this one is always on the top. So even if I'm not changing the scrubber because I don't need to, and I'm taking this out because I want to dry out my unit side, I know exactly which one should be on the top. So we have this top marker, and we have a clear procedure how to do the cycling. So which means this is the part of the course, but I will briefly tell you. When you do the cycling, once you take off the top scrubber, immediately you put it on the bottom and you immediately empty the top scrubber, the former top scrubber. So you never make a mistake like, okay, now the phone rings, you're distracted, and now, okay, I again put the top scrubber back to the used one. So the rule is, once you take that off, empty the scrubber immediately and put that on the second scrubber. So you always know that the one with the top scrubber marker on is actually the top scrubber. So theoretically they fit because we change them all the time between the places, but it's really, you must be stupid to do it, really.
Yeah, and you could put a used scrubber into any rebreather, so human factors is a super important part of that. Another couple of questions, if you don't mind.
Right.
Two people have asked us now, what's the scrubber duration? What's the scrubber duration?
That's the hardest question to answer in terms of rEvo. So sea scrubber duration is depends of the warm or the cold water. The cold water is 15 degrees Celsius and below. It's a cold water. 15 degrees, everything above the 15 degrees is a warm water. So we have always two scrubber times on rEvo. We call it cycle and scrubber time. Cycles time is simply when you can still do the cycling. You can simplify this as this is the time when you can still use the bottom one as a top, or if you need a longer dive, you can use full scrubber time. So we simply call it scrubber time, which means both of the scrubber have to be replaced after that time. So in the warm water, the cycle time is 3 hours and the scrubber time is 4.5. So maximum dive time on the rEvo in the warm water, 15 degrees and above, is 4.5 time, and then you have to replace 4.5 hours. And then you have to replace both canisters. And after 3 hours, you have to replace, you can replace the one and do the cycling. But those numbers actually are not too relevant because of the RMS. And I will get to the RMS maybe when we finish with all the questions for the moment right now, because this is a brilliant system for the rEvo, and I really would like to spend a little bit time on it. This is the system that is predicts how much time the scrubber will work. But I will get to that in a moment. So if you have any more questions, maybe let's...
Only two more questions. One of them is, the black cover looks really nice, but does it heat up more in the sun, causing thermal expansion? And the other question is, does the size of the unit change the scrubber duration?
Okay, so the second question is yes, no. They are exactly the same scrubbers in every unit. Micro, mini, standard, those scrubber canisters are exactly the same. Everything here is exactly the same. It's just the size of this housing is different, and it's only about to fit your body better. So the duration of the scrubber doesn't change. The heating of the black, you mean the black cover versus the yellow one, if it's heating up more? That's a good question, actually. It should, right? Because the black color attracts more sun, but you know, you don't leave any of your diving gear on the sun if you don't really have to. So I didn't test it, to be honest, but I believe, yes, I believe on the sun, it will heat up better than the yellow one. But again, you should not leave those parts on the sun. It's not only because of the heat, but also because of the ultraviolet, the radiation, and all this stuff, right?
And I guess, as far as I was aware, the black one's only for instructors and really cool guys anyway. Everybody else gets the yellow one, right?
That was only in the very beginning. As an instructor, you can get the black one with the instructor label on. But right now, you can buy the black one as a regular order. They are just only €200 more expensive because of the color.
Okay. Just really quick one, and then I'll let you move on with the unit. Why did rEvo/Mares decide to have the gas flow direction different to lots of other rebreathers?
To be honest, I don't know exactly what triggered that decision. I think that it's, as I told you, the Paul who was designing the units was thinking out of the box. And because I don't know any technical, let's say, disadvantage or advantage on the gas flow left, right, over right to left, to be honest. So I don't think that was the decision that was made that we have to do it like this because this and that. I don't know, maybe it's because I don't know what was the gas flow direction in IDA, the rebreather that Paul was diving in the very beginning. Maybe that this is how it's coming from. Yeah,
some of the military rebreathers had rich gas coming from the right and let lean gas going to the left, but you never know.
The designer's habits then.
Okay, buddy, thank you for answering the questions, my friend. Please carry on.
Okay, good. So then I would like to talk to you about two very nice design features about the rEvo. The first one is gas injection. So every other unit on the market has a gas injection separated into inhale and exhale side. So usually we have a diluent on the inhale side, the oxygen on the exhale side, and this is how it works, I believe, in every rebreather other than rEvo. I know maybe I'm wrong here, I'm not sure, but for sure the majority of the units have that solution. So in rEvo it's different. In rEvo we have the manual injection valve, our MAV that I already showed you once before. Okay, So MAV is brilliant. It's super simple to operate. You just have it here, very easily accessible, and you have 3 buttons. The diluent, the oxygen is inside, so it's easy to recognize it by feel. And then you can inject any offboard gas that you connect. So you can offboard the diluent, or you can offboard the oxygen, and just simply inject with this button. And here we have our let's say outlet hose that goes directly through the exhale counter line. So manual injection of both oxygen and diluent is directly into the exhale counter lines. And what is the advantage of that solution? So for those of you guys who are diving rebreathers, you know very well that the loop flashing procedure, so oxygen flash and diluent flash, is an important skill to master during the rebreather the diving, because you might have to do it in an emergency scenario. And because of this splitting injection into inhale and the exhale part in every unit, the procedures of the diluent flash and the oxygen flash, they are different. So just for example, let's say on JJ, if you want to do the diluent flash, you have to make yourself horizontally, tilt yourself slightly on the side, and then open the OPV on the counter line and inject the diluent button on other side. So you have to make yourself correct position. Otherwise, you will simply inflate full your counter lines, and most likely you will end up on the surface. On the AP with the front mounted counter lines, you have to do something like this. So you have to find yourself in a good position. The oxygen flash is usually very simple in every unit. You just press the button, you tilt your head up, and you let the gas go out around the lips. So the gas is going all the way around your units, and it's going out through around your lips. So the oxygen flash procedure is much easier than the diluent flash. And on the rEvo, that easier procedure, which is oxygen flash procedure in every other unit, also applies to diluent flash. So in other words, to make it simple, whatever, if I want to do the diluent flash or I want to do the oxygen flash, all I need to do is just to tilt my head up and press the button. That's all I need to do. So it's much easier. I don't have to fight with my position correct for the skill. I don't have to open over pressure valve. I just simply tilt my head up and press the button. And being able to do the full flash with the diluent or oxygen, doesn't matter which procedure you do, it is very important for your safety. Because for those of you who are not diving rebreathers yet, the diluent flash, for example, is one of the solutions for every problem with the gas inside the rebreather. Because the diluent is almost always a breathable gas. So if you have any doubts that your gas inside the rebreather is good, if you have any, let's say, symptoms of whatever, hypoxia, hyperoxia, you can always do the diluent flash, and then you know what gas you're breathing. You're breathing your diluent, which is air, for example, right? So diluent flash is very good. It's very important skill to master just for your safety. And for the rEvo, with the rEvo, it's super, super easy. And also, because of the countenance volume, it takes literally 2 to 3 seconds. Usually, the diluent flash procedure in other units, just because of the geometry of the unit design and the size of the counter lines, you have to flash the unit for several seconds. Depends on the unit, depends on the counter line size, but it never takes like literally 2 seconds. On the rEvo, if I do really this, now I'm breathing pure diluent, which is really nice, really safe, and really fast to react. So whatever happens, you just do this, and you know that you're breathing air, pure air, for example, if your diluent is air, or pure trimix if your diluent is trimix. But for sure, you know that you're breathing the safe gas. So this is very nice design, because I don't have 2 buttons on 2 sides. I have just one MAV here that allows me to inject any of the gases I want, whether it's diluent or the oxygen. And also, if I want to connect offboard gas, it doesn't matter if I'm connecting offboard oxygen or I'm connecting offboard diluent. I just connect it here and I inject it here, and that's it. So it's super simple, super nice, and this MAV is always super accessible. Even if you dive with a 4 or even 5 stages around yourself, you always have easy access to it. So manual addition is super easy. I never found any unit which so much easy manual injection as a rEvo. So this is because the oxygen and the diluent injection are exactly in the same place, which is exhale counterline in the rEvo. So this is the one thing I wanted to tell you, and the second one is already mentioned RMS. So the RMS, the rEvo monitoring system, is super sophisticated system that is brilliant. I love it. Everybody loves it, and it's brilliant. And also, if I didn't mention it, it's brilliant. So what is RMS doing actually? So RMS is the system that is doing actually 2 things. The first, it is constantly analyzing what's your scrubber condition and is calculating your scrubber condition, and it's displaying on the screen of your computer how much time in minutes your scrubber will last. So how does it work? Inside the scrubbers, we have this very funny shape for horizontal pins. These are temperature probes. You already know the temperature probes if you were watching the previous Adam videos from AP. AP also has a temp stick, which is a temperature probe inside the scrubber, simply because we know that when the CO2 is removed, the chemical reaction that occurs creates a heat. So if the CO2 reaction is on, there's a heat. So now if we can recognize if there is a heat or not, we can say that the scrubber works simply. We know that we always produce the CO2. If we are alive, we are metabolizing the oxygen, so we are producing the CO2 because the CO2 is a byproduct of the oxygen metabolism. So we always produce the CO2. So if everything works fine in your rebreather, you always have this chemical reaction somewhere. So you always have the temperature increase somewhere in your scrubber where that reaction occurs. So what rEvo has designed is this very fast responding and highly accurate. They can recognize the temperature difference of 0.3 Celsius. That's why they are so expensive. So they can recognize the temperature change very fast and very accurate. And also what is important, they can recognize this temperature difference not in the center row of the scrubber, but in this horizontal pin. Every pin is one. Actually, there are 2 temperature probes inside, so it can measure very accurate what's the temperature in each zone of the scrubber material. So now taking this data into the calculation and all the other factors that are actually affecting the scrubber duration, such as depth, the water temperature, what is actually even taken into consideration is your gender and your weight. You enter those data into the computer, so RMS knows how much CO2 you probably will produce. It knows what's the temperature of the water. It knows what is the depth, which also affects the scrubber duration. And now the RMS is taking all these temperatures measurement into consideration. And based on those data, it can calculate how much time your scrubber will last. And you have this information exactly on your screen. This is a little bit more advanced, but I will simply explain you why having dual scrubber and accurate temperature probes we can do it. Imagine that the gas is traveling, as I told you, first to the top scrubber and then it goes to the bottom scrubber. So if the first scrubber is removing all CO2, then there should not be any reaction on the bottom scrubber, right? Because there is no CO2. if there's any heat increase recognized in the first pin, the top pin of the bottom scrubber, it means some CO2 already has passed through the first scrubber, which means this scrubber is not anymore working correctly. We still have this one fully fresh. The second one is fully fresh, but as long, at the moment as it starts to heat up on the top, the RMS knows, okay, now the first one is gone or almost gone, because it's not always like 0, 1, 0, 1. It's a little bit here, a little bit here. But at least this is how he can calculate or measure where is our reaction zone, and based on that number, he can calculate how much time still we have. And now there was a question in the beginning, what's the scrubber duration for rEvo? I just gave you the C numbers because the RMS could not be a part of the CE testing. So we need to have a scrubber duration times if we have no RMS, and these are the numbers I just told you. But in real life, you have to think about one thing. What is actually using the scrubber material? Is it time? Because when you say the scrubber is working for 3 hours, yeah, or scrubber is working for 4.5 hours, but is it really the truth that the time is consuming the scrubber? Of course, it's not, because what is consuming the scrubber is the CO2. So it depends how much CO2 you will produce. Your scrubber will last less or long, or more or less. So if you imagine diving 3 hours in a strong current against it and swimming like a hell, and now compare this to 3 hours lying down on the sand with the camera and waiting for the picture of your life. Of course, the diver who is lying down on the sand will will produce much less CO2 in this 3 hour period than the diver that is fighting against the current entire dive. So that will affect the scrubber duration. But because we are not able to estimate how much CO2 we will actually produce during the dive, we have to assume something. We have to give ourselves some limits. And those limits are very simple. With the CE testing conditions, the unit is submerged in the Anstey machine, and then the breathing simulation is started, and then they simulate that your body, the machine, is producing 1.6 liters of CO2 per minute, which is a lot. To produce the 1.6 liter of the CO2, you have to metabolize around 1.7, 1.8 liters of oxygen per minute, which is really, really heavy effort. But you have to consider that maybe someday you will dive like this, so you need to know how much scrubber will last. So the CE testing conditions are very rough, because it's better to have a limit for the rough conditions and then use it in a better one and be safe compared to the opposite one, right? So we have those limits, but we know that those limits are for the very rough conditions, but we have to do it like this because we don't know, maybe those conditions will happen one day to us. And during the dive, we are not able to measure how much CO2 did we produce, so we have to stick to those limits. There's no other way to do it. But if we have the way to do it, because we can calculate during the dive by checking the temperature reactions on every part of our scrubber, we can then say, let's say after 1 hour, we used 15% of our absorbing material, because the 15% of the absorbing material has no reaction anymore, which means CO2 is not removed there, which means this scrubber is already used. So if we know that we have 2 scrubbers in total that can work for this amount of time, or this amount of temperatures should occur when it's still valid, then if we have those data and we have correct algorithm that was designed by rEvo, we can actually calculate how much time we can still breathe if the conditions will not change. This is a very important statement, because the RMS is always displaying on your screen how much time you still have before your scrubber will end at the same conditions at the moment when you look on that number. So if you are relaxed and you're swimming very, very relaxed and you're producing not much CO2, you look on your computer and you only see 6 hours. It's really a possible number. 6 hours in the warm water, if you're diving not very deep and you're not producing much CO2, you can easily use it for 6 hours, because in 6 hours, you will produce that amount of the CO2 that will completely deflate your scrubber. So you will see that on the screen. But now, when you start to swim against the current, because the conditions will change, you will start to produce more CO2. What that will affect is that there's more CO2, more temperature. So the RMS will very quickly recognize it. Okay, so he will recognize, okay, so the temperature inside the scrubber has increased from, I don't know, 45 degrees to 55, which means there's more CO2 coming in. So that means I have to reduce the scrubber prediction, and within 10 minutes from the 6 hours on the screen, you will get 4 or 3. Okay, then the current has stopped, or you swim away from it, and you go back to normal CO2 production. So what will happen? The temperatures in your scrubber will go back to normal. So this RMS will again recognize it, and then he will, okay, he will calculate, okay, so now less CO2 is coming in, so what has left will give you now 5.5 hours. So this is very nice system to have, because to summarize it, it gives you the real scrubber consumption or real scrubber usage measured in minutes, compared to just let's stick to the CE limits option, because it can actually measure how much scrubber did you consume based on the high accurate and multi-points temperature measurement inside your scrubber. So practically speaking, I'll just give you an example. My wife, she can do, I remember the trips when we was diving in Egypt, when we was diving not so deep, and she's very little CO2 producer. She did like 10 hours on the rEvo scrubber before the system told her you have to replace it. And it's really possible, and I know many people who can do it, especially females, because they generally they produce less CO2. They can really do several hours on the unit, and this is not, you know, this is not out of the blue. Right now we are talking about probably thousands, if not a million of dives in total done on the rEvo with RMS, and it works. I guarantee the system works. The prediction that the RMS gives us, I never ever had a problem with it. I never ever even heard about anybody had a problem. I mean, the problem that somebody had a prediction of, like, let's say 30 minutes, but he had a CO2 breakthrough. It never happened. So this algorithm is really accurate. It works. And the beauty of that system is that it adjusts the scrubber duration to your real CO2 production, not to the CO2 assumption, let's call it. So this is very nice. But what is even more important with the RMS is safety, because this is what I'm always fighting with the instructors and emphasizing during the courses, that we have to explain to the people how to use it correctly, because the RMS is not only about I'm consuming less line. It is the advantage of it, but it's not the most important. The most important is safety. If you think about it, how the RMS can save your life, I can risk the following statement. Using the RMS correctly, you can predict any type of CO2 breakthrough failure in your unit. And I'm gonna explain you why. So what may happen that you have the CO2 breakthrough in your unit? So what can happen with your rebreather that it's not removing the CO2 correctly? So let's take 2 examples. First one, mushroom valve failure. Okay, so your one-way valves that are actually creating the gas traveling only in one direction, which is necessary to simply push the scrubber, push the gas through the scrubber. If the mushroom valve fails, then I'm inhaling, okay? I'm taking the oxygen, I'm producing CO2, I'm exhaling, and now the gas with the CO2 is going a little bit on the left, a little bit on the right. Now I'm inhaling, so I'm sucking back the CO2. It will never get to the scrubber. And this is how I get the CO2 poisoning. So what will RMS do then? So imagine I'm breathing, so everything is fine. The CO2 goes to my scrubber, so it heats up at some level. Let's say random number 45 degrees is the temperature in the zone when the reaction happens. And now, from some reason, my mushroom valve stopped working. So I'm not pushing the CO2 to my scrubber, which immediately will create the temperature to decrease. So my RMS, he will not recognize it as a mushroom valve failure, but what the RMS will do, it will tell me now I had a 4 hours and 30 minutes prediction, and I look 1 minute later, I have 30 minutes left. So that should trigger an alarm in my mind that something is not necessarily correct, because if 1 minute ago I looked at my RMS and it showed me you have still 4.5 hours, and after 1 minute, when nothing has changed, I didn't produce more CO2, I'm not diving against the current, I'm not deeper, the water is not colder, and I see I have 15 minutes left, it means that there is no reaction zone. No reaction zone, no CO2 removed, and I'm still producing it because I'm breathing. So by correctly understanding the readings of the RMS, you can actually prevent the machine failures in terms of the CO2. If for some reason you will have breakthrough, let's say the channeling, okay? So for some reason you manage to make a channeling on the rEvo. So the gas will pass through that channel, so the absorbing material will be very fast removed around it, and then there was no CO2 removed in the scrubber, and the CO2 will pass through the scrubber. So what will happen? There will be no chemical reaction in the scrubber, so there will be no heat. If there is no heat, the RMS again will calculate that as reduced in the scrubber duration, so you will see it immediately on your screen. So again, if any other conditions didn't change, so you don't swim against the current, you don't go deeper, it's not colder, and your RMS prediction dropped dramatically in the short period of time, this is the indication for you that something is wrong with the scrubber removing system. And this is where you should go and write out and check it out. So wherever scrubber system failure you may have, it's always, if the scrubber system fails, it means it doesn't remove the CO2. If it doesn't remove the CO2, the temperature inside the scrubber will go down, and RMS will understand it as a scrubber is almost over, so it will dramatically reduce the prediction on your screen. And you should, as a diver, you should be able to read it correctly and understand it correctly. So if you know that this should not happen, it means something is wrong. So the RMS is not only about saving the line. It is saving the line as well, because it actually tells you to replace the scrubber when it is actually used, not after fixed amount of time. But the most important is your safety. By understanding how it works and learn how to read those numbers, you can actually recognize any kind of CO2 removing system failure. So this is the huge advantage of the RMS.
The RMS sounds fantastic, Przemek, and I can see you're really passionate about it. Couple of questions, if you don't mind.
Go ahead.
Greg said that some people complain that RMS is a bit hit and miss. What do you suggest to look after the temperature probes and keep it working properly?
Sorry, I had the connection break. Can you repeat the question?
Of course. Some people have complained that RMS being a bit hit and miss. What do you suggest to look after the temperature probes and keep the RMS working?
I just want to make sure I understand the question correctly in English. You mean that some people complain that the RMS is not working?
Yeah, sometimes it doesn't work. It doesn't come on. Not that it gives a bad prediction.
Okay. Yeah, sure. I know that I understand the question very, very well. Okay, so it is a little bit from the past. The first let's say, version of temperature probes, they had some issues that if the unit was maybe not even flooded, but it was too much humidity inside the rebreather, that humidity with the depth was pushed inside the probe with the pressure, and then there's electronics inside, and that's why the temperature probes was not functioning well. And the problem we had, it's that after a while, the temperature probe didn't connect to the system, because they connect actually wirelessly. This is actually the temperature probe connection, and it lays down on the computer board, and they connect using the induction technology. And in the beginning, the problem that is actually correct, there was a quite big problem, to be honest, in the beginning, that after a few months, one temperature probe didn't connect. So we had no connection, and if there is no two probes, the system will not work. First of all, it is now a lot improved. To be honest, since like a year or so, I didn't have any problem with the probes. All my students and their friends are diving rEvo with the new probes also. Luckily, they don't have any problems. So since like they fix it, the rEvo also told me that they found the reason why it was the problem, and they actually fix it. So basically, that was a little bit of the rEvo fault in the beginning, we can say, but now it's much more improved. The problem is not occur, or doesn't occur with the current, it's a rEvo. And also, if you have the older unit, you can always buy a new probe. It's not the cheapest part. I think it's something like 180 or 200 euros one probe. But once you replace it, and you have the new one from the new batch, and then it's much improved. What you can do to even help them not to break is try not to keep them in the humid environment for too long. What people will very often do is like, remember, there's always a lot of humidity in your scrubber, because the water is one of the reaction component that is needed. So if you know that you'll be not diving for the next week or so, even if your scrubber still have like 2 or 3 hours of production, empty. It's like 1.3 kilos a line. It's not much money. It's really not worth it. And then if you empty it, you let the probe air dry, and I'm sure it will improve the lifetime of the probe. Because the reason why we had that problem was simply the humidity that was pushed inside the probe once you were diving because of the pressure. So less around it, the better.
No, it sounds good. And with all these rebreathers, we got to go through a process of a little bit of development. As a rebreather manufacturers, they're relatively small companies. They do a lot of testing, but when you take something into the field, and technical divers aren't always the best with their machines, we figure out what goes wrong and fix it. So that's great news. A couple of questions from Sam. What is the stupidest mistake or shortcut that people make with this rebreather?
A good question. What is the stupid mistake? No, that's funny, because nothing comes much to my mind right now. Okay, I have one. Also historically, like 5-6 years ago, people were putting this, I don't know how you call this in English, because I call it schwami, but I don't know if that's correct word. This is the C-approved oxygen clean rEvo moisture absorbent.
It's a chamois leather, yeah.
Yeah. Okay. So we are using it like many rebreathers does. We are using this part to put in the bottom of inhale counter line, because there is a lot of space. So if there is any humidity or extra water, it will just soak in. What people were doing, they were actually putting those moisture absorbent into the exhale counter line as well, because there is also, as I told you, a space for the water. Okay, so, and this was a mistake, because as I told you, the counter line, they are one on top of each other. And right now, I'm actually squeezing the bottom counter line, so I'm blocking the gas to flow. Does it make sense what I just said, Adam, in English?
Yeah, absolutely. It makes complete sense. And just give me the name again. What's the real name for that pink chamois?
Funny.
No, the rEvo name.
The rEvo name is the C-approved oxygen clean moisture absorbent.
Sounds fantastic. I should order some to clean the car. And Sam's other question: if there's one specific part of this rebreather you could improve, what would it be? But I guess not much, because you are on the development team for the rebreather anyway.
No, actually there is, and okay, I cannot say that, but yeah, there is. So I would, what I'm missing in the rEvo actually is there is no shut off for the ADV. It's simply because the ADV is here. It's on a solenoid tray inside the loop. So there's this hose goes directly here to the first stage. So it's actually, there's no place when you could install the shut off. You could actually install it here on that hose, but it will be probably quite hard to reach it. So if I would improve something, if one day rEvo 4 will come out, it will for sure have it. The shut off for the ADV, that's the one thing I would improve. What else I would improve in that unit? I had something, because there were two things that was always bothering me that we could do better. The shut off for the ADV. Okay, and the second thing is the Molex connector. Because if you look, okay, you don't have to look, but you can see that the Molex connector for the oxygen sensor, they are permanently connected to the sensor board. This is the second computer. The first one is on top, and on the bottom is also the computer, the one that is reading the sensor readings and send it over the network to the other devices. And those cables are permanently potted inside that electronics. So remember that the oxygen sensors, they produce the current, and remember that there's also always humidity in the unit, just because you're breathing. So the current, electrical current plus humidity, they don't like each other. And the result is, if you don't dry this sensor tray after the dive, then you may get a corrosion on the Molex connector. And because you cannot replace the Molex connector, because it's permanently potted inside the electronics, you have to replace all the sensor board electronics parts, which is a little bit expensive. It's like also 230 euros or so. So if that cables, you could just simply disconnect the damaged cable and just buy the new cable, that would be nice.
Okay, cool. Well, another question. So when you pick the sensor board up there, a lot of people notice the rEvo has 5 sensors, yes, when all the other machines we've looked at so far has 3. Can you give me a little idea why, and also why the cost isn't as big as people would imagine?
Okay, good. So to answer for the question why the rEvo has 5 sensors, I have to explain what electronic options do we have on rEvo. Okay. So right now we have actually 2 options for the rEvo electronics. rEvo is basically based on the shearwood electronics. So we always have one main computer. We can call it the controller, which can be the petrol or, for example, NERD, right? So this computer has always 3 oxygen sensors, just like every other unit does. So this is why we have here 3 oxygen sensor, 1, 2, 3, and this is how the solenoid is operating based on, and so we change the set points, everything like on every other unit. We have the 3 sensors, volting, logic, and so on and so on. But then we always need to have a backup monitoring system. So, and now we have multiple options. We may have the NERD as a monitoring system. This is actually what I'm using in my unit right now. You can see I have also NERD in my unit. So right now, my main computer is my petrol with 3 sensors, and the NERD is my backup with 2 sensors connected into it. This is why I have 5 oxygen sensors, because 3 of them are for the petrol, my computer, my main control, and 2 of them are for the NERD, the monitoring system. The alternative for the NERD, the triple alternative, by the way, this is a mini. So you can see that it's not much bigger. Actually, this is the micro, but with a stand on, so you may not see the difference much. But you can see that on this unit, I have so-called a rEvo Dream. A rEvo Dream is very simple design, one sensor reading monitor system. It does nothing else, just display the partial pressure of the oxygen from one. Actually, it can be connected to two oxygen sensors. Then it displays in 3 seconds interval sensor number 1, sensor number 2, sensor number 1, sensor number 2. But what we usually do if I'm using the rEvo Dream, I have 2 rEvo Dreams on one unit, okay? And then the sensor number 4 and sensor number 5 is connected to the rEvo Dream. So this is actually a very big advantage of the rEvo. And I'm gonna say something right now that many people hate me for saying that, but this is true. The rEvo is the only unit on the market that has real electronic redundancy, because the rEvo is the only one unit by the factory default settings that we have real redundant systems. If you think about redundancy, is when the units are completely, the solutions are completely redundant. And in every other unit, even if you have 2 shearwaters, you have shearwater and a hood, you have 2 handsets, whatsoever, you always connect them to the same 3 oxygen sensors. So if the sensor fails, none of the electronics works. On the rEvo, it's different. Every electronics has its own computer, his own power, so its own battery, his own cable, completely not connected to any other electronics, and its own oxygen sensors. So they're actually completely independent. Whatever part of the system will fail, the other ones are fully functional. And this is actually redundancy. What we have in every other unit is not the redundancy. It's only display redundancy, we can call it. But if they are using still the same oxygen sensor, just for example, if you take JJ, we have hood and we have shearwater, but they're all connected to the same 3 oxygen sensors. In the rEvo, every electronics has its own oxygen sensors, so they're completely redundant. So this is why we have 5 oxygen sensors, to have fully redundancy. And the version with the rEvo Dreams, if we have 2 rEvo Dreams, we actually have 3 completely independent systems, because all of the systems has their own display, their own battery, their own cable, and their own oxygen sensor. That's why you may find on the internet the name rEvo Expedition. rEvo Expedition is simply the version of rEvo when you have the shearwater controller, whether it's a petrol or NERT, and 2 rEvo Dreams, because then you have completely independent 2 electronics. And if you go far away for expedition, like, I don't know, you go to Maldives or you go to North Pole diving, wherever you go, if any of the electronics fail, any part of the electronic system fail, you still have 2 working. So you can even go for the decompression dives. Theoretically, if we have let's pick any unit, okay, wherever unit you choose, if you have 1 computer and a hood, or you have 2 computers, if one of them fail and you're on a safari boat, you cannot go diving unless you're diving on decompression dives, because you should not go diving into decompression dives without at least 1 backup monitoring system of what you're breathing. So if you have the rEvo Expedition version, so petrol or NERT, and 2 rEvo Dreams, even if you're on a safari boat and on the second day 1 electronics fail, you still have 2, so you can still go diving, because you still have the backup monitoring system. So the 5 sensors is because the 3 are always to your main computer, let's call this controller, and then the 2 additional sensors are for your backup monitoring. And this backup monitoring can be the NERT, can be actually second petrol if you want, can be 1 or 2 rEvo Dreams. So this is actually also a very nice feature of the rEvo. Any questions about that, Adam?
No, it sounds like a really nice explanation of the two. And you choose for your personal machine a Nerd with 2 cells and a petrol with the other 3 cells, correct?
Yes, it's actually that was my choice. I like the Nerd. It's really nice. I like it, especially because it's very helpful for the bailout rebreather. I don't want to get into that too much because I will bore you too much, but the biggest problem if you dive with the bailout rebreather is how to calculate the decompression, because your rEvo computer is calculating everything fine up to the point when it breaks, and after it does not, your bailout rebreather is calculating basically nothing until you start breathing from it. So how do I get the accurate decompression calculation? And the Nerd, as a monitoring, has a nice feature since I think two or three last firmware update. Has a nice feature that during the dive you can switch the oxygen. How you call it? You can switch the option where is it taking the oxygen contents to calculate the deco. You can choose take it from the sensors, or you can switch to fixed PO2, like an external computer. So you can do it during the dive. That's why actually I choose the Nerd as a backup. So now when I'm diving on a bailout rebreather, if I'm bailing out on a rebreather, I just switch on my Nerd. Now you calculate my deco based on fixed 1.3 PO2, and then the decompression obligation on my Nerd is accurate because he knows what I was breathing before, and now he knows I was breathing fixed PO2 1.3, and the deco calculation will be accurate.
Okay, super. And again, I don't think the guys saw, but the rEvo Dreams also have a head-up display, so you get to see.
Yes. That was my mistake. I forgot about it. Yes, exactly. Thank you, Adam, for reminding me. The thing is that if you choose to use the rEvo Dreams, then each rEvo Dream has one head-up display. So because you've seen that unit has 2 rEvo Dreams, I have two head-up displays. There are 3 LEDs, the orange, green, and red. So obviously green, everything is fine. Orange is too low, red is too high. So you have it always in front of the mask, which is super safe. Good. So how are we with time? How much time do we have, Adams? Do we go?
We're going through the time quickly, but it's very interesting, my friend. So please continue if you've got time.
Okay. So because what will be good to do now, then I want to show you how to build up the unit. To do so, I'm gonna just take the loop off my unit.
Okay. While you take your unit off, I just have a quick chat to the guys. It's nice to see you all, and thank you for all your questions. Continue to ask us questions as we go through. Przemek's now going to go through the pre-dive assembly and the close check. So it's how to build the rEvo ready for diving. He can do it a bit quicker this time if you want to stay with us, because he's done a lot of the explanations as we go through. What you'll notice with the rEvo is that it's quite a quick build process, because it doesn't break down into too many parts. And that's going to be a really, really nice feature for when you want to build the rebreather in a quick space of time. Okay, buddy, you about there? Go ahead.
Right. Do you see the unit well, Adam, or you want me to adjust the camera somehow?
No, it looks perfect, buddy. Carry on.
Okay, good. So as usually, we are using the SSI checklist. So I have it printed here. So the first one is, of course, analyze the tanks and check the pressure. I already did that in my dive center. So I have my tanks here. This is my oxygen, and there is my diluent. So install both cylinders on the unit and verify correct installation. So as I told you, we have this quick time fixation. I just put 4 pins in, slide in, and it's there. Then I do the same with the diluent. Okay, it's on. Okay. Okay, so now verify the millivolts of the oxygen sensors. So basically, what I'm checking here is to make sure that my oxygen sensors are fine. So I just turn on my sheet water, check the millivolts, 10.1, 10.9, 10.5, so I'm within the range. I do the same for my nerve because there are two additional sensors, so I have to also check them out. 9.8 and 10.8, which is good. Okay, now the verify the youngest oxygen sensor is less than 7 months and old, 7 months old, and reading correctly, replace if necessary. So here I will start for the moment. So rEvo recommendation is you replace one oxygen sensor every 6 months. So you don't replace 5 sensors a year. You replace one oxygen sensor, one oxygen sensor every 6 months. And the reason for that is it's mathematically proven that this is the better way to rotate the oxygen sensors because you're reducing the probability that the majority of the system will fail. For those of you who are interested more about this, there is a nice article about this. It's called Understanding Oxygen Sensors. You can download this on the rEvo website, read it through. It's nicely explained. I'm not going to go into that theory right now, but if you replace one oxygen sensor every 6 months, you get much more, let's say, safety compared to replace all of them at the same time every year. So it is also, money-wise, much better because if you calculate, you spend two sensors a year, you spend money for 2 sensors every year compared to 3 or 5. So, other words, I just have to take a look on my sensors and make sure that that I have one sensor younger than 7 months, which means I did replace it, so I don't have to replace it yet. Here is one of my sensors. The sensor is from January 2020, so it's fine. Okay, secure the moisture absorber in the inhale counter lungs under the anti-collapse tube. So this is our CE-approved oxygen clean rEvo moisture absorbent. I just put it down here. So if there will be any humidity, it will stay there. Okay, install the sensor grid and the solenoid grid and verify if the cable routing is correct. So I just simply put my sensor tray here and my solenoid tray, I put it here. And now check the routing of the cable is correct, all is fine. No? So, next point. Fire the solenoid for at least 10 seconds or 3 times and verify if the external batteries reached greater than 6.5 volts. So my controller is my petrol, obviously. So I just simply change the set point to higher than it is right now. I don't know if you can hear it or not, but it's clicking. It's not firing because the tank is closed, but doesn't have to. It just needs to consume the power. Now I go back to my 0.19 set point and I can check now the voltage. I have 8 volts, which is fine. My battery is okay. So inspect the remaining time on scrubbers and if needed, refill. So I'm going to my computer. I want to show you the screen, which will not tell you much, but you will learn on the course how to read it. But here on the scrubber menu, I have, can you see it, Adam?
A little bit closer, buddy, just a tiny bit closer. There we go, we can see it, yeah.
Okay, so actually what I can read from this information is if I will dive up to 20 meters, my scrubber will last for 2 hours. If I will be diving deeper than 40 meters, then I have to reduce that time accordingly. I will not go into too much into the details, but here I have the log from the RMS that I can see after the dive I did last time on these scrubbers. I know exactly how much time I can still do. Actually, my scrubber 1 is empty because I told you I'm emptying the scrubbers if I know that I will not dive in for too much long time. So this is actually not the true, but if I feel the scrubbers completely new, I know I have for sure 4.5 hours. And then after the first dive with completely new scrubbers, I will use this actually feature to calculate how much time I use. Okay, so install the scrubber canisters into the unit. The top marker on the X-hay side, RMS arrows point up. There are small arrows here that should be pointed up. I'm not gonna go too much into details why is that, because then we spend here an hours. Okay, now inspect the scrubber O-rings, clean sealing surface with grease if needed. So here are my O-rings. I have to check if they are clean. Actually, I was cleaning them when I was preparing my unit for this presentation, so they are nice and clean. Also here, the sealing surface on my cover is good to just grease it from time to time, so it works much better. Now close the cover and screw it hand tight. So I just close the cover. I like to do it with the unit angled slightly, so it's easier to me. I simply just do like this, close the cover, and I have to find my screw. Okay. That's it. It's tight and it's sealed. Okay, now inspect the non-retromushroom valves in the breathing loop. So we do it the same way as we do it in every unit. Mine looks fine. Okay, so inspect the mouthpiece O-rings on the breathing loop and clean sealing surface. So O-rings on the loop are here. I just check if they are fine. I don't see any damages, and also the mouthpiece. Remember that inspecting the mouthpiece is important part of every rebreather checks, because the mouthpiece is the only part of the rebreather that doesn't take part of any test, but it is taking a part of your diving. So if you have a pinch hole here, there's no single test that will recognize it, but you will get the water in during the dive. So my mouthpiece is fine. Okay. So now install the breathing loop on the unit. So I simply install it on the unit. I just screw it hand tight. There's no point to screw it too strong, because it doesn't have any impact on the sealing. Perfect. And the last line of pre-jump check is wrap the hood cable 3 or 4 times clockwise around the loop. I don't have a hood cable, but I have my nerd, and I don't like to wrap the nerd around it. I just simply clip it like this, and I leave it outside. I think I didn't put my regulators in. No, why? I think we have here. We have to fix it because there is no information about the regulator on the checklist. Okay, so now, if you could see, my unit is fully built up, and actually it's ready to make a final test. Which we call the close check. The close check is a detailed check of every part of the unit, if it's working correctly and functioning properly. So the build-up was very simple. You've seen that my unit was completely stripped out. There's not much I could disassemble it from it anymore. So if we store it in the house or in our dive center or wherever, we just store it like that. So the scrubbers are out, the counter lines are open, so they can nicely air dry inside. The tags can be disconnected. What I did was just simply the unit build up. I just assembled everything to get together. And now I will just make all the tests to make sure that every part of my rebreather works correctly. And this is the test that you should do every diving day in the morning or whenever, but just every dive day. You don't have to do it before every dive. Before every dive, you just do the pre-jump check, but the close check should be done every day before you start the diving. So, slowly.
Przemek, do you have the little board that comes with the P-clip on it that we use, that comes with the rEvo? I think that's a really nice feature if the guys can see it with the close check and pre-jump.
The rEvo checklist.
Yes.
Yeah, I have it here. That's a good idea to show it. Hold on a second. So every rEvo comes with a checklist engraved like this. This is exactly what I will do right now, because on that checklist, we have the close check and we have the pre-jump check, the one that we do just before we jump to the water, just before we splash. And here is this close check where we check all this detailed function of the rebreather. So we have it, every rEvo diver gets it with the unit. So we usually clip it onto the unit and we always have it with us. I really like that idea. Okay, so slowly open the oxygen valve, check the cylinder pressure, and manually add gas to verify proper functions of the oxygen manual addition valve. So I'm slowly opening the oxygen tank. Okay, I have 100 bar. I take my manual addition valve. I just press and make sure that the needle is not dropping down. I know it works correctly. Now the next point is turn on the seawater and set point to high. Fire the solenoid for 3 times. So now I will actually hear it because the oxygen is open. I need 3 times to make sure it works correctly, and then I will check the battery. Remember that the unit assembly could be done yesterday, so the next day is also a good idea to check if the batteries are fine. Okay, change the set point to 0.19 so it's not firing. Perform 3 full oxygen flashes with the DSV. So I'm going to do the sensor calibration soon. So I want to flash the unit with the pure oxygen. And because the rEvo has if you remember correctly, the manual injection or the solenoid injection is in the top counterline and the sensors are in the bottom counterline, I cannot really do it this easy way like we have with the JJ or AP when we choose the calibration and the unit is firing the oxygen itself. If I do this with the rEvo, I will use much oxygen before the unit will actually be fully flashed, because oxygen will be injected in the top counterline and the oxygen sensor on the bottom. So I will spend too much gas to do it. So to make it efficient, we do these flashes, let's call it manually. So I will be inhaling the gas from the unit and exhaling the gas out through my nose. I do it few times, actually exactly 3 times, and so I know that in the unit I have pure oxygen. Okay, so the 3rd time when I did it, the unit is full of oxygen. Now I have to slightly open the gap so the unit equalizes the pressure, so there's no overpressure inside. So right now I have in the unit pure oxygen at ambient pressure. Good. So turn on the rEvo dreams and calibrate them. So I'm not using the rEvo dreams, I'm using the NERD as a backup monitoring system. So I will just turn on the NERD and calibrate it. Fine, and now the next point, calibrate the seawater. By the way, Adam, if you have, because you sent me this file, I think it's an old version because I see here some mistakes that we've corrected, I believe, you know? So we have to double check if you get it from the website or not. Because
sorry, buddy, I stole it from our ITD Dropbox.
Ah, so that's why. So probably we have to ask Kat. Anyway, okay. Verify the external battery reads greater than 6.5 volts. So I have still 8, so I'm fine. Inspect the batteries in the seawater and the NERD and so on. So I have to check here as well. This is good and this is good. Close the oxygen valve and verify if the pressure drops. So now I'm going to close the oxygen tank And I don't know if you're gonna see it or not. It is funny because this is the green and the green color is removed from that movie. But anyway, the needle is slowly dropping down. This is because the constant mass flow. So the constant mass flow is constantly leaking small amount of the oxygen. It's more or less the amount of your metabolic rate. So you always get inside the unit, no matter what, the amount of the oxygen that you're metabolizing. This is the advantage of the MCCR part of the rEvo. So to make sure that the orifice is not clogged, it's not stuck close, or I mean some debris just block it. You have to make sure that the needle is dropping down. It goes very slowly, but it goes down. So it means everything is fine and my CMF works correctly. Now depressurize the oxygen line, and now open the diluent tank. I open it. Okay, so breathe in any gas from the loop and verify if the ADV is functioning. So now basically I'm just breathing from my rebreather. And my ADV is not working because I had it off. Because as I told you, the one thing I would improve, I would like to have a shut off for the ADV, which we don't have in the rEvo. So I don't like ADV at all. That's why I completely turn it off. Don't do it at home. Okay. So close the loop and manually add diluent to verify the proper function of a manual addition button. So this is something that we were testing with the oxygen. Now I'm testing with the diluent. Okay, it's fine. The needle is not dropping. Everything is fine. Inflate the loop orally until the overpressure valve activates. So now I want to make sure that my OPV is working correctly, and which means I should be able to activate the OPV with my own lungs. If from some reason my OPV will, let's say, be stuck close or whatever happens that it doesn't open, I cannot activate it with my own breath. It means it's dangerous situation, because if I will be ascending too fast and I will not dump the gas around my loop or around my lips or on the nose, I may have the lung overpressurization issue. So I have to be able to activate the overpressure valve with my own lungs. Perfect. At the same time, I closed the loop when the OPV was firing, which means now there is slightly overpressure in my rebreather. I just wait a few seconds to make sure that the overpressure stays. Now when I open the loop, I should hear the gas coming out. It's a slightly effect because the loop volume is not so big, but it's fine. Okay. Now completely inflate the wing and verify if it holds its volume. Okay, so I like to do it early. Nice, stays. Okay, now flush with the diluent until the PO2 reach the PO2 of the diluent gas. So what I like to do, it's my personal thing. What we do here, we actually validate the oxygen sensors. Remember, we did the calibration of the oxygen sensor in the beginning, which means we simply told to our electronics, what you're reading now from the oxygen sensor is 1.0 ppO2 of the oxygen. If you want to validate if that was done correctly, there's no other way than expose the sensor to known gas and see if the readings are correct. So the best known gas we have is simply air. Air at ambient pressure will always have 0.21, or the gas in your diluent. The problem with the diluent is if that diluent is trimix, and for example, now in my tank I have 1070, so it means there is a 10% of the oxygen. So now if I will flush the unit with the diluent, I should read 0.1 partial pressure of the oxygen. So this is the one way to do it, but it will waste my precious trimix diluent and always will not give me super accurate readings because if my blender was wrong and instead of 10 I have 12 or 11, I may have a problem. I will be not sure if the reason for reading 0.12 is because of my sensors are wrong or because of my gas is actually 12%. I analyzed it before, but I was analyzing it also using oxygen analyzer with one sensor in it, so it's not that accurate. What I like in rEvo actually is if you want to expose your oxygen sensor on air, it takes literally few seconds because I didn't do my negative pressure test, so I didn't test the final loop integrity yet. I can open it now without any consequences, and within a second, I can expose my oxygen sensor on air. So right now, I should read 0.21 on my electronics, and that will be the best oxygen sensor validation I could get. It takes 2 seconds until it flash down. Perfect. I have 0.21, 0.21, 0.22, which is fine. And also my NERD is 0.21. So I like to do it that way. So no matter what's my diluent, I always have accurate sensor validation. So I know that my sensors were correctly calibrated and they are perfectly linear, at least between 0.21 and 1.0 range. So now I can close it back. It takes literally a few seconds, so it's not that big hard to do it. Okay, I put the screw back here, and I did my sensor validation. So now there's I have just 3 lines about my bailout tanks, so I'm gonna skip them. Now breathe in any remaining gas from the loop and perform the negative test. So now I just create a vacuum inside the rebreather. Okay, it's good to leave it for a while. Usually this is when I do my bailout. I just leave it on a negative pressure test. Now I can store my regulators, prepare my bailouts, analyze them if I want. I like to do this negative test for like at least 5 to 10 minutes. Actually, I found the rEvo very well negative test holder. If you have your O-rings really clean, lubricated, everything is fine, you can make a negative test right now, leave it over the night. The next morning you open the unit and you have full negative pressure still hold inside the unit, which is not happening a lot from my experience in most of the other units. It's probably because there's less connections here. We don't have, as I told you, no key connectors. There's only one hose on each side compared to 2 hoses. All those connections are additional sealing surfaces that can fail. rEvo have them much less, which is a lot, much resistance to leakage. So after a while, I just take my mouthpiece, make sure there is a, I hope you heard that. So my negative test was actually really nice. So then bailout. Okay, now I just ensure that correct gases are programmed in my free water. So I just check my bailout is actually it's 956, not 1070. Then I check my bailout. Okay, I have 50, 21, 35, and 1845. So that should be fine for my dive. Good. Now turn off the shearwater. Okay, clip it on the handle. Turn off the NERD. And that's it. Right now what I did, I just fully tested every component of my rEvo and I know everything works perfectly. I can now put it on or drive to the dive site or go on a boat. And the last thing I need to do, just when the unit is on my back, just before I splash, I just go over my pre-jump check to make sure my oxygen tank is open, my set points are correct, and everything else is working correct. So that's it. That's our unit build up. That's our rEvo build up. Do we have any questions, Adam?
Nobody. Thank you very much for the build. Really enjoyed it. very informative and lots of detail about, you know, the specific features of the rEvo that make it such an incredible rebreather. I thank you very much for your time. We've answered most of the questions as we've gone through. There's a couple in the comments that, you know, you and me can go and answer when we finish this presentation. But from my side, thank you for your time. And
thank you for inviting me.
The next rebreather we're going to do is going to be the Poseidon rebreather, this time again next week. We also have the Prism 2 and the Horizon coming up. So Przemek's favorite rebreather of the moment is the Horizon. He was heavily involved in the development of that. Maybe we'll see if we can get him along online to help us with that build. He's certainly the master of the Horizon.
It's so easy that you don't need any help.
That's the plan. Guys, thank you very much for your time. We'll see you all again soon. And thank you for joining us, Przemek. Goodbye, buddy.
Bye-bye.